Hello and welcome to section 6.11 trigonometric applications. Anytime you see applications in math, it means word problems. Don't panic. They're not as bad as you're thinking they are. They're actually kind of fun. Look at the fun pictures we get to deal with. All right, so a couple pieces of vocabulary that we need to talk about. Now, I want you to imagine there's a little guy standing right up here, right on the edge of that lighthouse. And he is looking straight out at the horizon. So he's looking straight out at the horizon, creating a horizontal here. I don't know if you can see that line. So there's like his horizontal view. Try a darker pen. Maybe you can't see that one. All right, now, if he tips his head down and looks to wave at somebody standing on the edge of the boat, right on the edge there, he has to tip his head down. The amount that he tips his head down is called the angle of depression. Tipping his head down is the angle of depression. Now, imagine this guy standing on the ship. He looks out, his horizontal, looks here straight at the edge of the cliff. There's the guy standing on the ship, his horizontal. And then he is going to look up, raise his head up to wave at the guy up here on the lighthouse. This angle, how much he has to raise his head up, is the angle of elevation. All right, now notice this horizontal and from this guy and the horizontal here, these guys are parallel to each other. See this coming right down here? This is sometimes called the line of sight. But you might recognize it as a transversal. So we have two parallels with a transversal coming through. That means this angle right here and this angle here are congruent to each other because they are alternate interior angles. And I'm going to go ahead and mark those guys as being congruent. And that's this note down here that I want you to write out. The angle of elevation and the angle of depression are congruent. The angle of elevation and the angle of depression are congruent because they are alternate interior angles for the two horizontal lines and the transversal. Which is the line of sight. Again, if I go too fast, please pause the video and rewind a little bit to get the information in. Okay, looking at the next page, we have this. A sonar operator on a cruiser detects a submarine at a distance of 500 meters at an angle of depression of 37 degrees. How deep is the submarine? All right, so cruiser ship here. going along in the ocean. The sonar operator guy sits right there, kind of at the bottom of the ship, right along the edge of the water. He detects a submarine out here. Here's our submarine at a distance of 500 meters. That distance is 500 meters. And at an angle of depression of 37 degrees. All right, angle of depression. Now, remember, angle of depression has to be how far you kind of tip your head down, if you will. So here's the water level out here. And if that sonar operator looks horizontally, he's looking out this way, horizontally along the edge of the water. Then he's going to have to tip his head down, or not really, but you understand what I'm saying if you kind of imagine it. He doesn't really tip his head, but he would have. That's how far down we have to go from the horizontal. That's the angle of depression at 37 degrees. And we want to know how far below the water, or how deep is the submarine. That's what we want to find out. When we set this up, then, this is just like what we've been doing for the past few days now. From this angle, 37, that's opposite. Here's hypotenuse, so that's a sine. Oh, if you can't remember this, jot it down. SOHCAHTOA. So sine of 37 equals the opposite, x over 500. Multiply by the 500. Pop into your calculator. Let's see, 500 sine 37 is 300.907. We'll round to 3 decimal places, so 300.908. 300.908 units. These are meters. So right there. All right. Let's take a look at the next one. A store escalator is set up as shown. How far does a passenger travel along the escalator? All right, so a couple of things we got to kind of figure out here. Kind of see a right triangle sitting right in here. So let's go ahead and finish drawing out that right triangle. I'm going to kind of use this edge here as to kind of complete out that triangle. There's your right triangle. All right, let's see, what information do we know? Oh, this is 32 feet. We don't know this distance here. We want to know how far does a passenger travel on the escalator. This is where the passenger is traveling. So that's x, that's what we're looking for. We need an angle now. And that's kind of given out here. This is 157. So if I look like over here, that's 157. Let me put it in a different color. Maybe this helps. This angle right here is 157. These two add up to be 180. There's that linear pair. So if we do 180 minus 157, that gives us 23. So this angle right down here in this right triangle is 23 degrees. Perfect. Because now we have an angle and a side, so we can find this length. Let's see, from this 23, opposite and hypotenuse. Oh, another sine. Sine of 23, opposite, 32 over the hypotenuse, x. Because the x is in the bottom, we can swap these two. So x is 32 over sine 23. 32 divided by sine, 23. And we get 81.898 feet. 81.898 units feet. Right there. Okay. Take a look at this next one. A 50-foot tree casts a 35-foot shadow. Now, we've talked about these shadow problems before. Sun's rays are coming down, hitting the tree. Right here, it's going to pass through. It's not going to be blocked by the tree. So this sun's ray is coming right down over here. Ground right there. These sun's rays are getting blocked by the tree, so there's no light over here, or limited light. So here's where the shadow is, along the bottom. And we want to know, how tall is that tree? All right, so we want to find that. All right, a 50-foot, oh, I take that back. We know how tall the tree is. Look at that. So a 50-foot tree casts a 35-foot shadow. There's the shadow, 35 feet. Oh, angle of elevation to the sun. That's what we want to find out this time. How far, if you're lying on the ground, do you have to tip your head up to look at the sun as long as we're wearing protective lenses? Do not look at the sun straight away. You will burn your retinas and you won't know it until many years from now. So don't look straight at the sun unless your eyes are protected. All right, let's set this up. To find this angle, I'm going to call it E for angle of elevation. Angle of elevation, let's see, we have an opposite and adjacent, that's a tangent. Tangent of E is opposite, 50 over adjacent, 35. So E is inverse tangent of 50 divided by 35. 55.008. These are degrees, so make sure you use that degree symbol to find that angle. All right, last one for today. A kite is flying at a height of 85 feet with an angle of 32 degrees with the ground. How much string has been let out? All right, so let's take a look at this. There's that kite that is 85 feet off the ground. The string is coming down this way. Okay, kite is flying at a height of 85 feet, so there is its height. Angle of 32 degrees with, oops, can't see it, I'm so sorry. 85 feet tall, angle of 32 degrees with the ground. Here's the ground. So 32 degrees with the ground. How much string has been let out? Here's the string right there. That's where the string on the kite is. Finding this from 32, opposite, and hypotenuse, this is a sine. Sine of 32 is opposite, 85, over the hypotenuse. So x is 85 divided by sine 32. And we have 100, 160.402 feet. That's the amount of string. Again, if I've gone too fast, please pause the video, rewind, hear it again, and email me if you have any questions. This is the end for day 1 of section 6.11. Your schedule shows only 2 days. There's actually 3 days of 6.11 notes, so there will be 2 more videos. And your question for today is, what are Mrs. Walker's 2 kids' names? What are Mrs. Walker's kids' names? And her boys' names are Ryan and Reed, R-E-I-D. So today, when you submit that you have watched this video, the question for today is, what are Mrs. Walker's kids' names? And you will write down Mrs. Walker's kids' names are Ryan, R-Y-A-N, and Reed, R-E-I-D. Thank you very much. Listen to you tomorrow. Bye.